Hello everyone, welcome back to theCUBE. I'm John Furrier, your host. We are here live coverage in Paris, France for the RAISE Summit. Here, two-day conference. It's an international event. A lot of people from the US here, a lot of entrepreneurs, a lot of companies and customers scouring the hallways, really looking at what's next in AI, and obviously it's a global stage, so a lot of talk about sovereign cloud, a lot of data platform discussions. Of course, there's a sub-conversation around infrastructure. Naveen Rao is here, he's expert in AI. He's the VP of AI at Databricks, entrepreneur, successful multiple exits. Naveen, great to see you again. Welcome back to theCUBE.
Thank you for having me. It's great to be talking to you again.
Thanks for coming on. I know you're a competitive race car driver, so we'll try to go super fast, but go slow around the corners.
There you go, precise.
Precise, right on target. It's going to be hard for me, but I really am excited for you. I think Mosaic was a great venture. Congratulations on the exit to Databricks.
Thank you.
But it really highlights what Databricks was doing directionally, data lake, and then now getting the use of the data.
That's right.
This is the #1 conversation in the industry that we have on theCUBE. We've seen also out in the hallways, in the booths, in the keynotes. My data is my intellectual property. I got to think about it differently.
Yep.
I got to process the data, like data processing, the old definition. I got to make it work. I got to get value out of it. I got to create value and extract value. I got to store it. So it's really the center of the action. This is an area where AI feeds off the data. What is your view on where we are on data relative to whether it's enterprise or hyperscalers or entrepreneurs? The data is the asset. It is the key underpinning element of all the success of AI. This is where the action is.
Yeah, I mean, honestly, I think Databricks is in a terrific position because of what you said. I would actually rephrase it a little bit differently. Data is the ingredients to make the asset. Yeah. Is really the way I look at it. So it's like you want to cook the dish, but you have to have all the pieces, and your data is really those pieces that will make something that actually has value. And for the last 25 years, we've been talking about gathering data, analytics, all of that, and basically ways to unlock value. Analytics, I think, were step one. Like, can I really understand my business better? Can I target things better? Can I improve products by looking at analytics? I think now we're looking at a point where the data actually defines IP that you can now have a differentiated advantage in your market. And how do you get there? Well, I think it's going to be some sort of using that to customize AI. That was really the thesis that drove the MosaicML acquisition by Databricks, was that, hey, we kind of figured out now how to gather the data, how to do ETL and some kind of basic cleaning and processing of the data. Now how can I unlock that value through AI by customizing models? That was the thesis. That is still holding true today. I think the specifics of how that's happening have been morphing and changing.
In what areas is morphing to, you think?
Well, I mean, I think, just using data to build models is not the only way to do it. You can obviously use it to contextualize responses. You can use it for fine tuning. You can use it for building better evaluation criteria to assess new kinds of models. So the manifestation of how you use the data is changing.
Jonathan Frankel was the chief scientist at Databricks, was on your team at Mosaic. He and I chatted at the Databricks Data Plus AI Summit around evaluation first.
Yes.
Talk about what that means, because this is not just throw data at the problem, be an ingredient.
That's right.
I mean, you'll have a terrible meal, right? I mean, if you do that. So talk about why evaluation is important, because you got agents on agents, agents for agents, it's like compilers for compilers, it's a science, but it's super important. Why is evaluation a key ingredient or key part of the step?
Well, the first thing before you do, forget about AI, if you do anything in life, you got to define what success is, right? Did I do the task right? Did I accomplish a goal? What was the goal? You got to write these things down. I think that's really what evaluation is what is the goal? What am I trying to accomplish? And how do I grade that? From 100% to 0%, like an exam. So I think that's why it becomes important, is that what we saw in 2023 was really people jumping into Gen AI. They thought it was magic, and it's just like, I throw a bunch of data at it, and magic will happen, and I'll get something great. But what is great? It doesn't know what great is, because you don't know what great is. So really, we said, hang on, let's figure out how do we first figure out what we're trying to accomplish, write that down in a very structured way. That in and of itself is actually quite hard to do. So what we spent a lot of time on, what Jonathan is probably talking about, was how do we automate that process, and then how do we allow people to update it, customize it, check it. and then use that as the basis to judge different techniques of building and customizing models with your data.
Yeah, and he was getting into some of the math behind it. There's actually probability theory.
Oh yeah.
There's a ton of input because a lot of the evaluation is agent-driven itself.
That's right, it's synthetic data. We're using these techniques. I mean, the way, I actually like to turn this whole conversation a little bit on its head. So generally people think of like, okay, I have data and I'm going to build a model from the data. So it comes from the very old side of things where, all right, I have a bunch of data points on a graph and I'm going to build a regression. Here's a line that fits that data, right? So I define the model, the line of the model is defined by the data. You can also do it in a different way. You could say, hey, I'm going to suggest what a model is of the world, and I'm going to use my data to check the validity of that model. That's what we're doing now. It's actually the inverse of it. So it's like, I think this should behave, these two variables should behave like this. And then I'm going to back check that against my real observations and say, does that hold up or not? If it doesn't, go search for a better model.
So observational data is key.
Observational is key, but it allows us to check a model that we believe, we hypothesize to be correct.
Yeah, as you brought up before, analytics was the old kind of industry, and it's a full-blown industry. I mean, there's dashboard businesses, tons of stuff out there. Now you combine and intersect that with Gen AI. What does that intersection look like? Is that where the, and then where's the tipping point? Is it tip to the platform engineering, data engineering side? Because now business logic is now involved. You mentioned IP.
Yeah.
So now you have kind of a seesaw between the two worlds.
Absolutely.
And they're different worlds.
They are.
What's your view on that? Because I think this is something that we're seeing. It's kind of early, but let's see the intersection, better word, but generally this is where the disruption
so
happen.
One manifestation of that we see today is, so obviously Databricks built a dashboarding tool. I mean, Tableau was a big one. We built our own. A lot of customers take their data that's in Databricks, their tables, and they build these beautiful dashboards that then they share with their management. Yep. Here's our financial metrics, here's our marketing metrics, whatever. Okay, so the next step is, well, instead of having these static graphs of that data or static cuts of the data, can I make that dynamic? Can I make it on demand? And that's the next generation. And really, we've embedded this now into our dashboards. So if you build a dashboard like you did before, you can say, give me a genie. That's what we call it. You hit that button, and basically now you can ask it anything of the data, and it'll actually do it on the fly for you. Yeah. It's producing SQL code, chopping the data how you're asking for, and then plotting it for you.
Yeah, I will say, you guys did a great job this year with Databricks, bringing that automation, that heavy lifting, the slog work. That's solid. What's next? What happens next? Because now you have evaluations. What's the progression look like in your mind as a customer who's like maybe a classic IT person, dealing with databases? How do you see it from your side? What's next after that? And then what does it mean to the customer? What do they do? Okay, I'm still trying to deal with my SQL. I've been working on SQL forever.
Right.
How do I level up?
Well, again, if you look at it from the framing of we're trying to extract more value from the data, I want to use my data as sort of that back check. So if we can come up with automated ways to suggest, here's all my data, and this is what I'm trying to do, so I'm going to give it a task description, I'm going to give it some data, come up with a model that sort of gives me something reasonable. Okay, back check it, give me an idea of how well it's doing. I have an evaluation. Now I can potentially go to limited production. So come up with, here's a set of users that can try this thing out. Okay, well there's some things that don't work. Learn from that, continuously update. Make that a self-learning kind of reinforcing loop that continually improves. That's the holy grail. Awesome.
I want to get your thoughts on infrastructure. You have a unique background. You sold one of your companies to Intel. You spent some time there. So you got a unique view into the machinery of how semiconductors people think. We're seeing massive re-architecturing of how the superclusters, I call them, or supercomputing. You got NVIDIA, you got Broadcom Tomahawk 6, great network fabric. You got Ethernet, open computes coming up, supercomputers coming up this year. We'll be covering those. How do you view the infrastructure? What are they enabling to make the data go faster? I mean, that's maybe the wrong way to say it. I guess what I'm asking is, what's going on at the semi level that's intriguing you? That you could, if you could do a mulligan over again, or if you could build the ideal cluster, knowing what you know, what would it look like? Because do I go with a neo cloud? does Amazon they got some GPUs, but CoreWeave's got more. I'm an IT guy, I just want the fastest horsepower because all the data is going to be accessible at some point, so it's kind of an arms race in the market. So the action at the semiconductor level will be a tell sign for what's to come, at least my opinion, but what's your view on this? What's your reaction to that? The infrastructure enablement, what needs to happen next? Obviously it's bounded by power.
Yeah.
What are some of your thoughts on that? I'd love to get your perspective.
Well, I think the name of the game is really about chip-to-chip bandwidth and memory bandwidth, right? That's what it primarily comes down to. I mean, the computing power you generally have enough of. It's basically like, how quickly can you get the information, packaged in the right way, processed by that compute, and then do something useful with it. So, all of these new technologies are really focused on those two things. How can I get information between chips faster, and then how can I get it in and out of memory faster? Everything you described just then, that's simply what it's doing. And really what that comes down to is, how quick can I get an answer from a model of a certain size? Yeah. The more bandwidth we have between chips and to memory, the bigger the parameter spaces can be. The more context I can use, the better the answer can be. Mm-hmm. So at the end of the day, all of these two things allow you to build models that can get you better and better answers over time. And I think, at some point we are going to crack this puzzle of how do we stop hallucinations, how do we ground responses truly in data. It's going to go hand in hand with what's possible with hardware. I mean, we've been really kind of hamstrung by what hardware could do. Like, you only had so much HBM memory available on your GPUs, so that limits how big a model can be. It limits how fast that model can be. It limits how much context you can bring into the model. That limits the quality of the responses. Yeah,
and then you got the word memory is twofold. You got memory bandwidth, high bandwidth memory, and then you got memory in the model so they can keep track of things.
That's right, yeah.
So there's two sides of the memory coin now.
But they actually are the same in a sense, because that context memory is a function of what your physical memory is, right?
So it's kind of like a Moore's Law kind of vibe, where it's like we got to keep the evolution of the hardware going faster.
We do, and I think we're also at a point though where the physics of the current paradigm are kind of getting tapped out a little bit. Like, you can scale. There was a time where we could keep scaling on the device level, and you hold the power budget and the dollars steady, and you kept getting more performance. Great. That's not true anymore. So now we scale on power. I can double my power and I get double performance, or I can double the area and I get double performance, or both. So we're not scaling anymore in a good way. So that's going to actually hit some roadblocks, because now we're talking about nuclear reactors. This is ridiculous to me.
Yeah, exactly. I mean, not to bring in the race car, because I know you're racing, but like how cars have changed, the performance, you can only squeeze so much out of the physical piece.
That's right, and so these thermodynamic laws actually determine what you can do, right? If you look at a car engine, right? It took 100 years to go from something that was in the single digit percentages of efficiency, thermodynamic efficiency from fuel, to now a state-of-the-art road car will be like 40% efficient. It took 100 years to get that, 10x in efficiency. So this is a hard problem, right? Yeah. We'll get there, we're going to crack it.
All right, so looking at the landscape globally, just your thoughts on Paris here, the event, some of the entrepreneurial activities high. If you were investing,
I am investing. I personally invest, and Databricks invests, and we are.
What are you looking at? What are some of the areas that you think are robust, white spaces or big markets to crack? What are some of your thoughts on some of the upstarts? Because they're the young guns and older folks that have systems background are coming back in the game. Because if you're a systems person from the 90s or even 80s like me, you go, whoa, I know this game.
I'm a systems person from the 90s.
Yeah. So what do you like? What's on your card?
Well, I would say we're kind of in this golden age right now, where people are willing to try big things, which is amazing, right? Yeah. So I think the big things are really how do we now start to define what intelligence really is? I think this hallucination problem is actually tied hand in glove with that, because we built these big models. They kind of do some stuff. Are they really truly intelligent? No, because they don't really understand causality. Now we're talking about ways of doing chains and this and that. So I think those are the big bets that I'm seeing. And I think some of I would say the downstream places where you can take advantage of it would be coding and design. Anything where I have an engineering design process, like coding is an example of that. It took off first because we have lots of examples of code, but if I'm designing a bridge, I can express it in code. That's the thing that I think is going to start, not being, I wouldn't call it disrupted in the sense that like everyone's going to lose their job. I hate that narrative.
I
think it's stupid.
I do too.
But I think what I can do as an individual engineer will just be like amazing in 10 years.
The creativity is going to just skyrocket.
I look at it like, imagine Leonardo da Vinci with a tool where he could ask it anything like on the internet. Imagine what he could have done, right? The things came out of his head without any of that. Was amazing. Imagine what he could do if he said, well, what if I did this? What if I did that? Try this, simulate this, simulate that. If he could do that just on the fly, you could do, move at light speed.
I mean, I love the whole art and science now. It's just so awesome. I totally agree with you. I think there's going to be a Cambrian explosion. And I think the intelligence piece is an interesting one. 3 years ago, we published a thing on SiliconANGLE and theCUBE Research, a power law of models. This is when OpenAI just came out. And our thesis was, you're going to have a long tail of specialty models. Are going to have different, kind of a little bit, 80% right, but it panned out. I asked Jonathan months before the summit, I go, okay, models need to talk to each other. Okay, and that was my thesis, okay. But because you have, no one model would rule the world was actually my thinking, and I think that's become clear.
It's still true,
So as fusion happens between data, because it's a data problem, cyber's dealing with this, the models have to have intelligence about each other. What's your view on that, and how does that look going forward? Because it makes sense that you're going to tap a certain part of your brain if you're Leonardo da Vinci. The prompts also create a second order effect, because now you have an answer. That changes the context of anything. So I see model interaction as a big thing. With Mosaic, as you cleaned up the automation of pipeline, that's step one. I'd imagine step two is, hey, I want to take the best of the CUBE model that's very narrow, of all the linguistics of the CUBE, where all those experts mixed together, we're talking. Now, we have a model, but again, all of our transfers, they're just vector embeds. But like, I would say that might be valuable if someone pinged me and said, what's Naveen's vision? That could be valuable in one little context to something else that switches a bit. I mean, I'm making that up on the fly, but the riff is, models should talk to each other. Do you agree?
I agree, but I think the way they talk with each other today is pretty impoverished. We do everything through context or tokens, and that and it basically goes through the English or human language. I think what we need to do is actually have some ways of even potentially standardizing representations and having ways to actually take those things that are processed versions of the prompts and the inputs to then kind of like mind meld between the different models, right? That's still new. No one's thought about it yet.
Well, it's food for thought. Final question for you is, what are some surprises for you? I'll share my surprise for the year. We're midpoint, so we're halfway through the year. I loved MCP, I love how that emerged. Some people love it. A2A is out there. That's kind of been a rallying cry. Is there a de facto AI stack thing happening where you're starting to see traction around, kind of solidarity around just getting on the same page around creating some sort of standard around AI portions of the stack where developers can just like, okay, we just agree on this. I mean, Iceberg was one, I love that. But okay, what else is out there? What's your thoughts on this? Because in every move, my experience is that there's always some sort of de facto kind of collective consensus around something. Is there anything that you see that you can share or thoughts?
I haven't seen too many consensus things yet. I mean, obviously like the transformer architecture, sure, great. But even the attention mechanisms are quite a bit different between different models still. And then you have like different ways of breaking up the embedding space through like mixture of experts, things like that. So there's no real clear standard that's emerged there. There's been some new ideas that have come out that have been pretty interesting, state-space models, that kind of a thing. So I think those have some potential. I think protocols for models talking to each other still isn't really well defined. We're still doing it all through context. Even vector databases tend to do that. I think the vector database themselves are getting better, and they're getting more tuned to the kind of use cases that you have in AI. Vector databases were born out of search from years ago, right? So I think those are now getting better and maybe kind of being standardized in the way they act.
They seem great. I mean, they work good. It's good low-hanging use case. If you got a lot of data, make it searchable.
And I think now we're kind of a bit more mature on how that actually is part of the system. It's not like RAG makes it all work 100%. That's not true. You have to do a lot of work to make sure that context is pulled out the right way at the right time to give you the right answer. And so I think that's all still evolving. But honestly, like, I don't think it's settled down yet. It really hasn't.
Yeah, it's exciting. If you're to give advice to folks that are making generational bets right now, you start to see on the enterprise side a lot of backlog of POCs and very narrow path of production. RAG gets through because it's simple. It's an easy use case. It's not super like mind-blowing, but it's good use case for finding data. A lot of the work gets done for you. I see that. I'm cool with that. We use it. What is the enterprise backlog challenge? Advice for folks, whether they're IT departments or business executives looking at business transformation, what advice to set up that data layer to think generationally? I want to do a 5 to 10 year journey. And I don't mind being intentional, I just want to get it, I don't want to get it wrong. Is there a directional correct playbook that you would share to your best friend who's betting the farm on their company?
Because I end up talking to a lot of like senior people at large enterprises, all the big companies you know. And so evals first. What is your problem? What are you trying to solve? How do you grade it? That's the first thing you do before you even start any of these projects, right? The other one is then also UI. This is the one that people don't talk about as much. I gave a talk on this topic at Mobile World Congress earlier in the year, and I think the UI is actually the thing that reduces the friction to a point where something becomes useful, and then you see a giant uptake. And then you start to get a lot of usage data on how something works when it doesn't work, and you can really refine it. If you don't get the UI right, all the downstream steps break, right? And I think that's something that's not been thought about. I've said it in many talks, I hate the chat interface. I think it's the worst way to consume AI most of the time. I mean, obviously if you're doing a chat or a search, maybe that's fine, but like, when I'm coding, I don't use chat necessarily, right? I use chat maybe for one part of it, but I want answers presented to me when I'm using them, when I need them. You want it
in the fabric of the application.
Exactly. So understanding really how a workflow works and what you're trying to automate is key. So like, inside of a company, my suggestion for people is like, form a group that's basically focused on AI and automation, and it almost becomes like a product management exercise. Go and understand the workflow. This is what this person does on a daily basis. This is how much time they spend in this step. Okay, how can we make that step faster? How do we present information to them in that moment that makes that task go faster? It's a product management thing.
I remember during the days of the web, the joke was, make it faster, simpler, and easier to understand. I mean,
same thing's true.
It's like, it's a sign of success. Naveen, great to have you on theCUBE, and again, congratulations, great to know you. You're a distinguished entrepreneur, one of our mixture of experts in our database over the years, and again, congratulations, thanks for coming on, taking the time out of your busy schedule.
Absolutely.
All right, Naveen Rao, VP of AI at Databricks, successful entrepreneur, and his finger on the pulse on AI, and obviously doing great work. MosaicML sold to Databricks, again, big success there. But more importantly, this is the future, generational shift happening right now in the industry, and a lot of opportunities for entrepreneurs and companies to transform. I'm John Furrier, host of theCUBE, thanks for watching.